Alright, so now let's come back to job module. We are going to create a new job, and let's name this as monotonic and continue. So there are a couple of things here. The first is the more or less the same, but the parallelization is when you would like to use multiple processor, but that depends on your computer and your in your PC, that how many processor and cores do you have. If you have a very high processor in the computer, so you can use multiple processor. So that's the thing to consider. But I don't have super fast computer now, so I'd like to do with something very basic. And let's see what error, what problem that we will receive now, and then we could refine those with the passage of time and see. I'm gonna submit the job here. So the job is submitted, and let's see what warnings, what error that we are receiving, and then we can refine those warnings and all those things. So yeah, it will take time because I have very refined mesh and a lot of complex geometries there. So yeah, so it's running, but I'm not sure when this will start. So for the first time it takes some time. I also had a couple of other things open in my PC, like the Word files, some PowerPoints, some PDFs, some other stuff, and some browsing stuff there. So that's why my computer is already, I'm gonna close probably this browser, but still have the other browser running. Probably that I can't close that because there are a lot of pages that I've opened. But anyways, for your model to be running and you want them to be fast, first thing is you need to have a very good computer, and the second, try to close other windows and other running programs. That might help. But anyways, I'm gonna stop the video now because I'm not sure how long it will take. It will take a lot of time, and when there is some error pops up, we're gonna go through that error and discuss things together, and that's how we'll proceed. Alright, so it's started, but there are very discontinuities, and it took more than one iteration to solve the first step. And then again, yeah, I could even can increase my processor because I just came to know that I have 8 processors in my, or 8 cores in my processor, so I can do that. But anyways, we'll have update soon, so I'm gonna pause the video again and see what's happening. Yeah, so again you can see the time step is 0.0025, which is too small, which means that it will take a couple of hours to complete, and I can't do anything else on my computer now because the software is too heavy, and everything else is frozen now, and I can't even just close this. But anyways, you can see, so we have submitted our job at 14:25, and so 25, and now I have 31, which means in 6 minutes it only have 2 steps, and there will be thousands of steps. So that's why you have to wait for a couple of hours to do that. So, and that's how we'll do it. But anyways, let's wait and see if there is any error, any warnings. Other than that, there are a couple of warnings, but I don't think we have the rebar outputs, but surely we don't have that. So there are some nodes that have been adjusted for type pairs and stuff, so that's normal. Anyways, okay, I'll see you in a moment and see what's going on here. Alright, so we had our analysis terminated by the error. The time increment required is less than the minimum specified, and there are no robot in the message file. Let me see if I have anything specific. Yeah, so the see that the solution appears to be diverging. Convergence is just unlikely, so the time increment, yep. So all those things we can play those things in our step module. So automatic stabilization, I would specify that the dissipated energy by fraction of as is, and then incrementation. Yeah, I don't want to really reduce my incrementation further, because yeah, probably I need to reduce this a little, but anything else should be okay. The method, and okay, and this method. There's one thing though I forget, is the history output. So I don't want anything for the energy. I'd like to have this not for the whole model, but yeah, I can define a new set coming toward the mesh, and so I'd like to create a set. Where is that? Inside assembly module. So yeah, let's name this as output. Should be nodes, and continue. Alright, so I want this somewhere like this point, and that's for my displacement, and for the force, which will be the reaction force, I could just do any one point. That's one thing, or in fact I already have that because I'm applying it on the other direction. So yeah, that's why I need to have those two and then summation of those. Alright, so I already have the sets. I need to define those two sets for my history output. So the sets is fixed. This is my fixed, the boundary condition, and I really don't need that. So for the boundary condition, I'd like to have my stresses and also the forces, but I'm more interested in forces. So it will be reaction force, but in y direction, and that's it. Create another history output in the set loading points. I'd like to have the data at every increment, and that should be my displacement, but in u2 direction. That's it, and dismiss it. So I also have those. I have those already. So for the model, I have failure and fracture, damage, and I have other things like the stresses, the strain, displacement, forces, and okay, I could remove this here and dismiss it. So now in my interaction module, everything seems to be okay. kind of having feeling if those 2 points are overlapping each other or those are square point. I'm gonna check the x-axis. It should be x-axis, this point and this point. Yes, so that's there is a problem we have here. Let me see, because that is 0.75 and the other is 0.5. Let me check for the other one as well. This point 127 and this point. Alright, yeah, both of them are not in contact with each other. That's the point. So what I'm gonna do, I am should be the x-axis should be 0.5, so I'm gonna copy this, come to assembly, translate this, turn this point, and instead of 0.75 it should be 127.5 and press enter, and okay, now both of them should be aligned. I'm gonna quickly do the query again. This point, so it's 152.5, this point, yep, and this point 127.5 and 1, okay, cool. So the error could be because of this, because these two are not in contact with each other, and we have defined general contact, and that could be the reason. But anyways, let's just continue with our, I'm not sure whether I should, I'm gonna reduce my mesh because this thing is like taking forever. So instead of 8 I'll go with 12, apply, done, delete mesh, yes, and yes, mesh the paths in the assembly. You can see it's still good. So an angle and the base plate is 15, apply, delete mesh, okay, again. Alright, let me see, because if I delete the mesh of the upper plate and the lower plate, I need to create those two sets again, because there will be new points, right? But anyways, I'll create those sets again, but I have to reduce my mesh. I really don't want to be this much big. I can make it like 6 or 7. Apply, turn, and mesh it. Yes, yes, should be okay. And the other bolt should be 8. I'm gonna also do the 8 for the other bolt as well. Yep. 8, delete the previous mesh, turn, mesh the part, yes. Lower part, I have no other choice. 15, delete the mesh, okay, yes. I can even make it a little more bigger, like 20 instead of 15, and because those are bigger plates, let's just do with 20. And also the base plate, same, 20, apply, did mesh, okay, mesh again. Yeah, it's not that much good, but anyways, we'll see. Probably shall keep it as 15 because I'm kind of having feeling it's not good for the convergence. Yep, this one looks good. And my lower part is again 20. Apply. Yes. And the lower part, the upper part, and the weld. Finally, I can choose like 8. Okay. And there you go. Everything is now meshed again. But once again, I have to see those sets are now, you cannot choose those sets, they are no longer available. But what I'm gonna do is edit those, sorry, again, and turn, and same with this loading points, edit those. Oops, let's make sure you do not, yes, cool, and done. Alright, the one thing is, let's check our interaction sometime, because whenever we have some changes that got this dot here or something like that. Yep, looks good. Just miss it, chop, and coming to the job again and submit it. So the job has successfully submitted. It is running, and we will see how things will be this time. And we have everything we need, constraints, and yep, that's it. Yes, the request for replaced by okay, 69 nodes have been adjusted.
We were playing 2 versus 2. There was a team up match.
Alright, so the thing is that it was pretty good in the start. If you can see here, there is no iteration now. It was running smooth. So yeah, after some time now I'm getting error right now because of exact the same thing. And let's see if I have anything in the warnings. So yeah, the strain increment, that's something we need to take care. It's all related to the material properties that we have. And you know what, let me try to see some results if I can. So alright, so yes, so that's the point actually. You know, there's sort of deflection in my base plate here. Anyways, we will take a look at those things. We can see those bolts are under some stress. Yeah, anyways, let's so come back to, so these are the things that now we need to take care. I'm gonna come to my message file to take a more detailed look at those error and stuff. So now we have, we can see that the solution appeared to be divergent. Time is too many times. The analysis has been terminated due to the previous error. and we can see that the force equilibrium not achieved. Alright, so now what we can do, I'm gonna turn on the non-linearity. I'm not sure whether that would considerably affect my results or not, but I can do that. And incrementation is F. So that's the other thing is I'm gonna take a look at my material properties. Probably the bolt for the plastic strain of my bolt is really big. I'm gonna make it 1.25, and there you go. Again, submit the job. So these are the things that you need to play. It sometimes really is problematic. So it might, you might have to work on it for a couple of days, probably a couple of weeks, and in sometime couple of months to resolve this issue and to come up with the ideal behavior, particularly in the case when you do not have exactly the accurate material properties for your model. Sometimes you can get that from experimental work, but if you don't have this from experimental work, then you need to dig into literature and you know uh, and you need to just get all those from your literature. But anyways, so yeah, those are the loads. So fixed, no, alright, I completely messed up. I need to, because those two sets are completely opposite, so I need to kill my job here, dismiss it. That's why there was kind of deflection in my angle here, because I applied load from this side. This has to be fixed. So what can we do now? So that's the fixed. It should be, yep, it should be this actually, but what I'm gonna do is I'm going to cancel it, rename it. Oh, not resume, come on man, rename it. And I'm gonna name it monotonic, but let's just put 1 here, so that's not to do the repetition. That's monotonic, and that should be fixed, right? Can come to the loads. So the fixed name is fixed, so that just can edit that. Nope, just I'm gonna delete those two. Yes, delete those, create new. Let's say this is my fixed from a very beginning, initial step, displacement, rotation. So yeah, fixed, continue, and I'm gonna fix the rotation. Why did I not rename those? Boundary conditions. Alright, why do I only have one boundary condition? Oh, I just defined that. Sorry, my bad. The problem is not with actually my bad. The problem is with the sets that I have. So those are the loading points and those are the fixed points. So those should be my loading points and the other should be fixed one. Loading points, and okay, and this should be fixed. Okay, where is it? Just delete, oops, not suppress, delete it. And again, boundary condition. So the first one is the fixed in the initial step, and the fixed, and continue, and so those are now fixed. Make sure, yep, that's correct. And again, create a monotonic displacement and rotation, and should be this. Continue. Nope, nope. Create, it should be the monotonic. You should choose the step here as a monotonic, and then the load, and then in the U2 press 1, and there you go, dismiss it. Alright, so now I have everything set up here. Come to the job, submit, and okay. Alright, so the following history thread do not exist. See, yep, because we changed those names, right? So field output is okay, but the history output, oops, field output, history output should be, yep, I know, sets, and it should be the loading. So for the loading, I like to have displacement in U2 directions, and for the history, yep, sets and loading, I like to have the forces, reaction forces into, and dismiss it. Come to job, submit. Okay, now the job is submitted. Alright, so now again the analysis is terminated. Now this time at 15 seconds. The total duration was 25 if I'm not wrong. So yeah, the screen increment is too long. Let's see the result this time. So as you can see, yep, it's too much. This thing is going because there is too much strain here. So that's how it's. Let me start the animation if I can. Animate time history. So that's how it's. But because I did not define the breaking or thing like that here, so that's why it's just so much flexibility in the model. Yes, if you want your steel plate like to have, sometime it might break here, so that's you need to specify that in Abaqus. So that's how it is done, and we can visualize different other things, like for example the I'm gonna let me see, where is the so the history output, and I have all those reaction forces here. I can plot them, as you see how the reaction forces is going, and to do that I'm just gonna sum up all those, and reaction force all the way up to here, so I can save it as 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 average of this thing, and okay, so this is the average force that I'm getting now. Similarly for the displacement all the way up to here, I can just plot this, or I can just save it as again the average, and okay, dismiss it. Coming back to here, I can simply, what I can do is just simply XY data manager, and I can simply plot, or another option that I have is just history output and then each step separately. Yeah, so now I have those data points, and what I can do is again choose create xy data, operate on xy data, continue. So now I have this two data here. What I can do is here choose clear expression. Let me see, combine. There should be an option of combine. I'm not sure which one was x-axis and which, but anyways I'm gonna just see. So now it should be the other way around, so that should be force and displacement. Clear, combine this and this, and boom. So that's how my force deformation looks like. So this is how we're gonna model our bolt connection. There are a couple of lot of other things, like if you are interested at strain at any particular any particular point or whatever is that. So yeah, you can always play with those things. So, and again, it has to be, if you'd like to simulate something exactly experiments, you need to be very careful with all the dimensioning and material properties that you have, and specify if for example if this thing is gonna fail or damage, or there will be a crack propagating. So you have to specify all those things. Alright, so that's it. See you in the next video.